In this video, we're going to be reviewing the activities and tasks for practice 1, which involve calculating exact percentiles from a rank order distribution with continuous dependent variable values. So recall that there are differences between continuous and discrete values. Continuous values do not have a specific pattern in terms of the ratios that can be assumed by the data. So this literally could be any value possible from 0 upwards, because 0 at least in this example, is representing the absence of a measurement. So we're looking at ratio data where the decimal place can be pretty much whatever it wants to be. Our instructions involve a scenario. So we have a set of data from individuals from a swim team. And what we did is we collected race times in seconds for 4 different strokes. And these individuals are being compared to multiple individuals who competed at a swim team. So we're kind of hand-picking about 5 people. We've got their swim times from this meet, and then we want to look at those values compared to the rest of the people who swam at the meet. So let's go to our data spreadsheet, and we will calculate the exact percentile for each team member based on their 100-meter swim times for each stroke. Our spreadsheet looks something like this, so we can see 4 different strokes, 5 people, all of their raw score data times, as well as the times for everybody at the meet. And you can see each of these data sets has a different number or sample size of people who competed in that stroke, so we should keep this in mind when we're performing our calculations. When we're calculating based off of rank order data, when the number can pretty much assume any value, using a COUNTIF function is the easiest way to get our cumulative frequency. So you'll recall from lecture that when we're looking at either rank order data or a simple frequency distribution, we want to take the cumulative frequency at a given raw score and then divide that by the sample size to get our percentile. So what I'm going to do is I'm going to insert 2 columns in between each stroke. And one column is going to represent the cumulative frequency. The next column is going to represent the calculated percentile that we're looking for. And just so we clarify, we are calculating exact percentiles using this method. Okay, and because I love color, I'm going to make my cumulative frequency column yellow and my exact percentile column blue, just so we can see the difference and we don't get confused with all the numbers that we're going to be calculating. From here, I can highlight these 2 sets either as the data or kind of data range that we would have values going into, or I can also copy the columns. Either way should work. I'll copy that and then insert my copied cells. We'll then get an option to shift the cells to the right or down. I want to shift my cells to the right. And then I think we have to do this process again. So copy, insert copied cells, and we can continue to do this over here. And just because I have pet peeves about column widths being the same, I'm going to change these so they match the rest of the data set. Excuse my OCD tendencies. Okay, so we have kind of a skeleton set up for our calculations. And the other thing that we're going to add kind of below our people is the sample size. Okay, because we noted that the sample size is a little bit different for each stroke. And it would be helpful for us to know, or at least have a reference to our sample size as we go into calculating our percentiles. So the easiest way to get sample size is to use a count function. I'm on the freestyle stroke, so I can just highlight all of the data in the freestyle column, insert that in my count function, and I get a sample size. So we can do this for backstroke. We can do it for brushstroke. And butterfly. So I'm just using the count function, inserting the range of data for each stroke, and now I have the respective sample sizes, or n, for each of the races that occurred. For my cumulative frequency, recall that when we start to make a cumulative frequency, or when we want to start building how many people were able to achieve a certain value or below, we have to consider what the distribution looks like. So I'm going to draw very poorly, but when we have, let's say, our data are normally distributed, and our mean is in the center, so we'll call that x bar. On this side of the distribution, we have the 100th percentile. And on this side of the distribution, we have the 0th percentile. As we move through our distribution, our scores go from worse down here all the way to our best scores up at the 100th percentile. So based on the units that you are using and the units you're measuring, you have to decide what is on the worst side of the distribution versus what is on the best side of the distribution. In this instance, we are looking at time. So that means the fastest times are going to be on this side, right? So fast people. And on this side, these are going to be our slow people. Okay, so higher times will be on this side, right? Or numbers that are greater in value will be on this side. Faster times will be our smallest values. So this is why I kind of use caution when I explain percentiles, is that you don't necessarily want to say a percentile is the percentage of people that performed at or less than a certain value, because in this case our greater values are over here, our lesser values are over here. So if we were saying less than, we technically would be moving in that direction. So I always say values that exist at or worse than a particular raw score of interest, just because of this phenomenon. So when we're calculating, I'm going to get out of my drawing tool. When we are calculating our cumulative frequencies, in this case, we're going to use a COUNTIF function. And what we're interested in is all of the values that are at or worse than a particular value. In this case, worse than values are going to be higher swim times. So our criteria is going to be a greater than operation. So we can do equals COUNTIF. We only have one set of criteria, which is going to be our raw score of interest. So we're going to work off of our freestyle data. That's our range. We put a comma, and then we identify our criteria as our freestyle time for the subject that we are looking at. Okay, and the criteria reference is going to be greater than the reference, right? So any times that were slower or had a greater time value are what we're going to be looking for in this box. Okay, we can then see that there are 61 people, and if we wanted to double check this, we can say where's 48.3, or what value is closest to 48.3 in our distribution. And then we see that there's kind of this discrepancy here. So if we highlighted all of the data that were below, we can see the count, or the frequency, is in fact 61. So our function worked. Yay! We then want to copy this downwards. So we need to freeze our cell range so that it doesn't move. We do this by inserting $signs in front of the row references. And then we're able to copy this downwards to find the frequency. You can see our range stays the same. Our reference to our subject is correct. And we've got our frequencies calculated. Now we want to look at the percentile value, which is going to be the cumulative frequency divided by the sample size times 100. Now we want the sample size to freeze in space, so we're going to do the same thing and put a $sign next to the row reference so that way it doesn't move when we copy this function downwards. And now we've calculated our percentiles for each of our subjects. So you can use all of those procedures that we just covered to calculate the cumulative frequencies and percentiles for the rest of the swim strokes.